I'm David from Oakbio. I'm the CEO of the company. What you see here is a flue gas stack, one of the many in the world that are emitting 400 billion tons a year of greenhouse gas carbon dioxide equivalents. And it was in the shadow of one of these that our CTO and founder, Brian, grew up in the next town over in Cupertino, within sight of the Lehigh cement plant there, which puts out 1.2 million tons of CO2 a year then and now. Brian was an environmental activist in college regarding this particular plant, and then 2 decades later returned to that plant with a technology he had invented to take those CO2 emissions and transform them into valuable products. And so today we're going to talk specifically about PHA biopolymers produced through a bacterial process, gas fermentation of that CO2. Now, PHAs are a broad family of bioplastics. There are literally millions of permutations chemically, and correspondingly, they have a lot of applications in a variety of industries and for a number of uses, and from the low value to extremely high value biomedical applications. So the chemistries, again, are varied, and these different kinds of PHAs can be achieved within these bacteria through genetic modification. And that's really the trick. It looks like this. Each of those white granules is a chunk of PHA that the bacteria has used to store energy in a similar way to how humans and other animals use fat to store energy. Up to 90% of the mass of a bacterium like this can be PHA, and it's relatively easy to separate and purify. Producing PHAs in this way has some real advantages in cost over making them from sugar or from methane. Not just in terms of what's probably the lowest cost feedstock, waste industrial carbon dioxide, but also the growth, the cell density, the genetic tractability, and the tolerance for real world flue gases, not just from cement, but from other industries, including these other 5 that we think are particularly applicable. Our team is uniquely qualified to pursue this, given the experience in microbiology, in molecular biology, in bioprocess engineering, and entrepreneurship. And when you look at our broader team, in our careers, we've built more than 10 million liters of standing fermentation. As for the opportunity today, perhaps for companies in the audience, it's to take advantage of the fact that there's been significant investment and time put into this general biomanufacturing platform. We've been pursuing a business on the nutrient side and would like to do one also in polymers. And this would build off of our intellectual property and knowledge in gas fermentation systems and synthetic biology. What we don't know and what we're seeking is on the polymer side, a group that has knowledge on the material science and the markets for polymers. What that might actually look like, a spin-off of our company, of a separate biopolymers entity, jointly funded development, and given our track record in raising venture capital and networks there could also be significant third-party investment. And then the partner could have access to the manufacturing through either a direct participation in a joint venture, licensing and doing their own manufacturing, or purchasing the product. So please come talk to us upstairs. Thank you very much.